Hello everyone, this is Mr. 13 Things again coming at you discussing this concept of transformations, but also trying to tie you into some of the great tools and some of the tricks to using them effectively. And so you notice now I'm capturing just a field here. In other words, this thing I know I'll try to move it around a little bit less. That cursor is actually capturing a full sheet of 1280 by 720 paper. What I'm going to do is I'm going to show you one of the things and talk about what's off to the side, this ability to do with layers and actually push layers off onto a transparent background. Just learning to really get to use Smooth Draw at all its levels. This has a lot of value. Sal Khan is using it for capturing, and it works pretty well. I'm running off of also a Bamboo tablet, which I would recommend anyone doing this type of work getting some kind of decent, they're about $70 a tablet. It's a pretty good investment even if you need to have a little bit less of a computer to afford that $70. There are other things out there that'll do it. Your smart boards, your capture devices, we used to call them digitizers in engineering when I started so many years ago. So what I'm going to do here is I'm going to go ahead, I'm just going to leave this as a white background now, and I'm going to actually, off on the side you don't see, I'm going and I'm adding a new layer. So now I'm actually working on a new layer. So we're talking about matrix transformations, and if you remember, I'm going to again talk about this point here now, about this point individually. So we'll assume that that's an X and this is a Y, and if you remember me talking earlier about these standard colors, we're going to actually go ahead and try to draw that X direction as red and this Y direction as green, right? So that's X and Y, and you're going to see later that Z is coming out of the board. So, and Z, of course, I'll just go ahead and do a little bit of that so you can see it. That Z is going to be this little blue coming out. So this concept of when we talk about some point up here, put that back to black, and realizing, oh, now I probably want to go ahead and go through this whole concept of colors. So I'm going to fill in a black thing here. I'm going to go and use my sucker here and draw in a red. I have to keep on doing it. Grab that red. I'm going back and forth to the pencil. That's doing the clearing. I've got red. And I'm going to go ahead now and use the sucker. I'm using the eyedropper there. I'm going back and forth on the pencils, and I've got just pretty much the three colors that I need here for what I need to do. And so I'll go ahead now and think about going to my screen sucker here, a point that's maybe right here. I'm going to grab that, remembering to go pen back and forth. That point there, which I'm going to call, believe it or not, point 0. Now, once again, teaching students that sometimes you start counting at 1, but in computer science you start counting at 0. And so I'm going to tell you right here that I'm going to give coordinates of point 0. Let's say that has coordinates of in the order of 1, 2, right? The ordered pair. Right? So students can start to realize, oh, 1, 2, but let me right away, maybe in the short term, see that realistically until you train your eye, and when you start going into different dimensions, you have to start training your eye to color. You maybe, and you can't keep it up, it's too difficult. 1 is the X, and again, working here. 2 is the Y. So now we're going to do this because you're going to see later on when you're dealing with more than one point, you don't want to have them have the same X and the Y coordinate. So you've got X and Y, and now we can go back and grab that there. I'm just going back and forth on the pencil, and I can also say that point 0 looks like this. Again, click on the red, back and forth on the pencil. It is 1. Back and forth here, green, back and forth, 2, and finally that third one is going to be blue, so let's see if we can suck up the blue, and then back and forth on the pencil. there. Okay, that's how that point. So actually we'll go ahead back to the black. And that's some of what you see. I think you see Sal Khan doing off on the side of the screen, just so you know. And he'll probably show you how to make some videos. Doesn't want to give away too. He's giving away all his tricks. Okay, so point 0, the first one in a list of points, it looks like that. Now, I do this for the reason that when you start talking about your transformations, I'm going to go on and sketch those up right here. Right now, all this is on layer 1, right? This is all on layer 1, which you don't see. But right now, I can do this. I can export the layer image, and I can stick it out to something. And you want to go ahead and put it in PNG format. I'm going to put some letters here and hit save. Well, now I pushed that out, and we'll see later that it pushed it out on a transparent background. So this ability to go ahead and now add a new layer that you can later on go to things, turn things on and off like this. And you're not seeing what I'm doing off on the side, but I'm actually using layering, which is in many ways, if students might think about it as another dimension, and they probably are doing that in their game. So right now I'm drafting on layer 2, but layer 1 is on. So this concept of layering is a very old, tried and true concept that came about in the old days in drafting, when we had different sheets of mylar or vellum that was clear material that you could kind of see through from one layer to the other. If you think about it, onion skin paper. All right, so this is your point, and if you remember, what we're going to do on a regular basis is still learn to extend that with a extender of 1. So this here, think about this. This is the point, right? And this is just the scale factor. Right? If you want to give it a name, that's what it is. It'll always be 1, and you'll almost always ignore it. I do this for this reason. I'm going to now go ahead and let's say I wanted to move that point down 2 in the y direction and over 1 in the x direction. I wanted to actually move that point to there. And so that point, the second point, you're going to see point, which is 1, is going to be, in this case, what? It's going to be down 2 in the y. Actually, did it more. If that was 2, I moved it down 4. That's 2, and that's 2 more. So I want to go down 4. So that's a minus 2, and up 2. This looks like something like that. 3, comma, minus 2. That's that second point there. All right, so you might think you did that, and mathematically it would be correct to actually did that by subtracting 4 and then adding 2. But in reality, here's what that looks like if you're going to do a translation transformation. I'm going to go ahead and start with my point 0 right here. My point 0, and now I'm not going to use the colors. I'm just going to say my point 0 was 1, 2, 0, and then of course the 1 scale factor there. And I'm going to think about it, but I'm going to leave blank spots. So I don't. I guess I won't. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then 0, 0, 0, 1. So having students always start with the identity transformation and then learn that later, I'll do it in dashes, this is going to be what's going to be scaling it and rotating it. And these three values here, x, y, and z, are going to be what does the translation. So in this case, if you think about it, I wanted to change my x a positive 1, so I'm going to see if I can use this here. Go ahead and erase that. Edit, cut, and I'm going to erase, change. I'm also going to change that. Edit, cut. Again, showing you some of the technique, clearing, going back to the pen here. And now what I'm going to actually do is go ahead and realize I'm changing my x by 1. So my x translation is 1. I went 1. I'm sorry, I said 1. I keep on saying it was 2. I moved 2 in that direction. And minus 4. Once again, I will point out, at this point, you plug this in and plug that in, and you will end up with what you know is the case, a vector that looks like this, 3 minus 2, 0 because you haven't changed the z and you still got that. But you want to not necessarily train students to think they're going to do it by addition. They're going to do it by transformation, which is always a multiplication. And we can just do the first one before I end this video. It would be 1 times 1 is 1, plus 0 times 2 is 0, plus 0 times 0 is 0, plus 1 times 2 is 3. When you add the 1 and then the 2, you get 3. The second row, 1 times 0 is 0, 2 times 1 is 2, 0 times 0 is 0, and minus 4 times 1 is minus 4, so you get the minus 2. And so transformation, no matter if it's translation, rotation, or mirroring, or which would be reflecting, or even shearing, is a multiplication process, a multiplication process. And so we spend years showing students that you just add one thing to the other, when realistically most of the transformations are done always by transformations, which are a multiplication process. You are multiplying a matrix by a vector and getting a vector. As you do more and more points, you'll just be doing 1 point, 2 point, 3 points. You can be doing as many points up into tens of thousands of points per second. That is in fact how 3D games work. And if the kids are playing them, they should be mathing them. Thanks for listening.